Example 3. You pay an installation fee and a monthly fee for internet service. The table shows the total cost for different numbers of months. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the total cost as a function of the number of months. Okay, so first of all, the first question is, can the situation be modeled by a linear equation? Well, keep in mind if something is a linear equation, it has to have a constant rate of change. So a constant rate of change, I'm going to start over here with my independent variable, which is my x. Just a little recap here, this would be your domain. And I'm going to find my rate of change. So 3 to 6, I go up by 3. 6 to 9, I go up by 3. 9 to 12, I go up by 3. So far, so good. Then I'm going to go to my dependent variable, which is my cost, is my y, also called my range. From 176 to 302, I go up by 126. 302 to 428, I go up by 126. 428 to 554, I go up by 126. So given that everything here is constant, I would probably say yes, this can be modeled by a linear equation because it has a constant rate of change. Now, specifically, we have to go one step further because the months are increasing by 3 months every time, and the cost is increasing by $126 every time. But I really want to know, okay, well, how much is the money actually increasing every month? It's kind of like a unit rate if we think back to 6th or 7th grade, which means I want to find my slope. So my slope is always my change in y over my change in x, meaning my dependent variable over my independent variable. So my dependent variable y is changing by 126, while my independent variable is changing by 3. So 126 divided by 3 is going to get me 42. But if we interpret that, because this was money and this was months, that's really $42 per month, which is a constant rate of change. So yes, because it has a constant rate of change of $42 per month, and that's a positive 42 because the money is going up. If the money was decreasing, it could potentially be a negative number. Now, if possible, write a linear model that represents the total cost as a function of the number of months. Okay, so I'm going to say, well, I have a slope. Do I have a y-intercept? Meaning a y-intercept is when your x value is 0. So are any of these over here 0? And the answer to that is no. So I'm going to revert back to my point slope form of y minus y1 equals m times x minus x1. You can pick any point you want. You could pick 3, 176, 6, 302, etc. Again, I'm going to pick this one just because the numbers are the smallest. This is your x, this is your y. So y minus the y value, 176, equals the slope we found was 42, and then x minus the x value, which we're using is 3. If we go from here, I'm going to have y minus 176 equals 42x minus, I have to use my calculator for this, so give me a second. 42 times 3 is 126. Then we're going to add 176. So y equals 42x plus 50. And essentially, this is your equation. Now, I'm just going to change up one thing here because here we have y, here we have x. Well, x is really the number of months and y is really the total cost. So instead of x and y, to make this a little bit more meaningful, because it says linear model that represents the total cost as a function of the number of months, I'm going to make y my total cost equals 42 times my number of months plus 50. And that would be my equation. And then just one more thing to interpret. It says the table shows the total cost for different number of months, and it said you paid an installation fee and a monthly fee. Well, if I take a look at this, what would be the installation fee and what would be the monthly fee? So the monthly fee is your $42 per month. Sorry, monthly fee, which is your slope. You're paying $42 every month, whereas your 50, that's your y-intercept, is your installation fee. So it's kind of like the one-time fee to come out, set everything up, and then from there, you just pay $42 every month that you have the service.